Rational equation. Equations that contain rational expression are all rational equations. Rational equation is an equation containing at least one function whose numerator and denominator are polynomials. These fractions may be on one or both sides of the equation. Example, 5 over 8 minus 3 over 5 equals x over 10. Clear away all fractions, the 8, 5, 10. Let's find the least common multiple of 8, 5, and 10. The least common multiple of 8, 5, and 10 is 40. Next, we multiply every fraction by 40. The first fraction is 5 over 8. The next one is 3 over 5. The last is x over 10.
Rational inequality is an inequality which contains a rational expression. So before we will proceed to our example, we will first review about the interval notation. This is very important because you are going to write your answer in an interval form or interval notation. So how to do the interval notation? Let's say we're going to check or test our final answer. So we are going to use the number line to test our final answer. Let us first familiarize the different symbols that we're going to use in interval notation. If you will encounter this symbol, this is what we call the open, and the shaded part is what we call the close. And if you will encounter this hollow circle over here, we will use parentheses. And if our circle is closed, or the shaded one, we will use a bracket sign. So, now let us say our final answer, we have this output. So, negative 3, we have a hollow circle. We have a hollow circle here and going to positive infinity. Open, then write the number negative 3, comma, then we are going to positive infinity. Since we don't know where it ends because this is infinity, we are going to use the open symbol. So, open negative 3, that means negative 3 is not included, then going to positive infinity. So, another example. Let's say that this is our final answer. We have negative 3 and positive 5. So, let's start on the left side of our number line. This is going to negative infinity. So, since we don't know where it ends, so this will become open negative infinity, comma, negative 3, it is shaded. So, this means negative 3 is included. Since this is closed, we will use a closed sign, which is the bracket. Now we have another answer in the positive side, so we will going to use union. So open positive 5 because this is a hollow circle, then comma, going to positive infinity, and we will going to use parentheses.
We have here an example of x plus 3 divided by x minus 2 is less than 2. First step, we'll transpose 2 to the left side in order for it to become equal to 0. So we will have x plus 3 over x minus 2 equals 0. Next step is we'll find its LCD. So negative 2's denominator is 1. So our LCD is x minus 2. Next is multiply the LCD to negative 2 and we'll have a result of a numerator quantity of x plus 3 times negative 2 times the quantity of x minus 2 equals 0. Next, in order for it to be simplified, we'll distribute negative 2 to the quantity of x minus 2. So we will have a numerator of x plus 3 minus 2x plus 4 over x minus 2 equals 0. And to be simplified it more, we'll combine like terms. X minus 2x equals negative x. Positive 3 plus 4 is 7. So we'll have a numerator of negative x plus 7 over x minus 2 equals 0.
Step 2, let us apply additive property. Negative x plus 7 is equal to 0. Simply transpose positive 7 to the other side. So this will be negative x is equal to negative 7. Let us divide both sides by negative 1 so that the negative here in our x will be cancelled out. So it will be x is equal to positive 7 because negative 7 over negative 1 is equal to positive 7. So to the other side, x minus 2 is equal to 0. Let us transpose negative 2 to the other side. So it will be x is equal to positive 2.
We have already found the values of x and we'll plot it now in the x-axis. So we'll get an interval of negative infinity, 2 and 2, 7 and 7 and positive infinity. Step 4. We'll be now testing the intervals of which is true and which is false, which is usable and which is not usable. So number 1, we'll be testing the critical point negative infinity to 2. So in this case, you are feel free to choose any value that is under negative infinity to positive 2. So in this case, I chose 1 and let x be 1. So substitute 1. So 1 plus 3 over 1 plus 2 is less than 2. So this will give us a result of 4 over negative 1 is less than 2. And in order for it to be simplified, negative 4 is less than 2. So this statement is true. Next step is we'll test the point 2 and 7. So I have chosen the value number 3. So substitute 3. 3 plus 3 over 3 minus 2 is less than 2. So simplify, we'll get a value of 6. So is 6 less than 2? No, so it is false. And the number 3, test point 4, 7 to positive infinity. So I have chosen the value 8. So substitute 8 plus 3 over 8 minus 2 is less than 2. Simplify, we'll get 11 over 6 is less than 2. So this statement then is true. Step 5. We'll now put an indication star in order for we to identify which interval is true. So the true interval is negative infinity to positive 2 and 7 to positive infinity. So the solutions are open parenthesis negative infinity to positive 2 union with open parenthesis 7 to positive infinity and close parenthesis.
Graphing rational functions. How do we graph rational functions? So here we have our example and our equation. First, we need to find the horizontal asymptote. To find the horizontal asymptote, we must first know the three conditions where n is the highest degree of the numerator, m is the highest degree of the denominator, a is the numerical coefficient of n, and b is the numerical coefficient of m. If n is less than m, then y is equals to 0. If n is greater than m, then there is no horizontal asymptote. And if n is equals to m, then the horizontal asymptote is y is equals to a over b. So in our equation, our n is equals to 2, and m is equals to 1. Since n is greater than m, then there is no horizontal asymptote.
To find the vertical asymptote, we must first equate the denominator to 0, then solve for x. In our case, 4x minus 2 equals to 0. We transpose negative 2 to the other side and divide both sides by 4. So our vertical asymptote would be x equals 1/2. To find the x-intercept, we let y equals to 0, then solve for x. So our numerator is x squared minus 1, then we equate it to 0, so x squared minus 1 equals to 0. And transpose negative 1 to the other side, so it's x squared equals positive 1. And then we get the square root of both sides, so our x-intercept are positive 1 and negative 1. To find the y-intercept, we let x equal to 0, so we substitute x in our equation, and we got y equals to 1/2. So our y-intercept is 0 and 1/2. We then make a table. Choose at least 2 numbers before and after the vertical asymptotes. In our case, we have 7 numbers, and we need to substitute x to our given equation.
As you can see in our graph, the red broken line represents the vertical asymptote and no line for the horizontal asymptote. Then we plotted the coordinates from the table. You can see that the line gets closer to the vertical asymptote, but doesn't touch it nor cross it. And sometimes, we could cross the horizontal asymptote, but never the vertical asymptote.
Find the domain all real numbers except the vertical asymptotes, so all real numbers except x equals 1/2. And range all real numbers except the horizontal asymptote. Since we don't have a horizontal asymptotes, all are real numbers.